Okay, I'm going to draw the unit circle real quick. Not the whole thing, but circle. Okay, we're going to talk about trig identities today. When we made a triangle in the unit circle, we call this point xy. We also said this could be remember that? Mm-hmm. Okay. So if this is 1, the Pythagorean theorem tells us x squared, or sorry, if this is x, this is y, x squared plus y squared equals 1 squared. Right? So x squared plus y squared equals 1. Okay, so once we know this, and we know that x and y are cosine and sine, this is one of the most important trig identities that you should know probably for the ACT, because you may have one question. And it's this. Because x is cosine, y is sine, so I can say cosine squared or sine squared plus cosine squared equals 1. Okay? From this identity, I'm going to write it down here. I'll just do it this way. I can derive 2 more identities that are part of a large number of trig identities. And to do that, the first thing I'm going to do is divide everything by sine squared theta. Okay, so when I divide sine squared by sine squared, I get 1. Cosine squared over sine squared, well, maybe we should take a minute and remember our inverse identities. So what's 1 over sine? Cosecant. 1 over cosine. Yep. Okay. So cosine squared over sine squared is cotangent. Right? Because we know sine over cosine is tangent. So if I switch this, I get 1 over tangent, which is cotangent. Yep. And so cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. So there's another trig identity.
Would you be able to open up my Word 1.4 again so I can finish it?
Yes. Can you give me just a minute to get through?
1.2, 1.4,
2 and 4?
Yeah.
Okay.
Thank you.
Cotangent squared, cosecant squared. So I could do the same thing and divide by cosine squared. Sine squared over cosine squared is tangent squared. Cosine over cosine is 1. And 1 over cosine squared is secant squared. So these are the 3 you're going to see the most as far as, what do they call them? Identity properties, something like that. Pythagorean properties is what they are. So you have sine squared plus cosine squared is 1. 1 plus cotangent squared equals cosecant squared. And then tangent squared plus 1 is equal to secant squared. So those are your 3 Pythagorean identities. Okay, these are called inverse identities here. Okay. The other thing to think about, if I could draw a right triangle. No, let's go 30, 60, 90. Okay, if I wanted to know sine of 60, well, if I label these, I could even think about the unit circle, right? Sine of 60 is going to be the third one up, so it's 1/2 square root of 3 over 2. So sine square root of 3 over 2, but we'll prove it here. Sine is, or sorry, sine's 1/2, sorry, 1/2, no, square root of 3 over 2. Right? No. Yeah, sine of 60. Yes. Okay. If I wanted to know sine of 30, it's 1/2. Cosine 60 is 1/2. And sine of 30 is square root of 3/2. So what we've figured out here is the sine of 90 minus theta is equal to cosine theta. Right? Because sine of 60 is 90 minus 30 is equal to cosine 30. This should have been a cosine. I'm losing my mind. Right? Sine of 60 is equal to cosine 30. Sine of 30 is equal to cosine 60. So sine of 90 minus theta is equal to cosine. Cosine of 90 minus theta equals sine. Tangent of 90 minus theta equals cotangent. And then cotangent 90 minus theta equals tangent. Okay, and you could just draw a quick triangle. You're going to see problems that say you're given a triangle and they say what's sine 90 minus theta. So you could either draw the triangle or just remember that that's equal to cosine theta. Okay. What are some others? Domain and range. So let's think of sine theta, cosine theta. When we look at the unit circle, and any triangle I draw in the unit circle, is there any number that could make sine or cosine undefined?
270 degrees? Or like all the 90 degrees?
Well, what do I have to have in the denominator to make something undefined? 0. And will the denominator of sine and cosine, given that the unit circle is 1 for the radius or the hypotenuse, will it ever be 0? It's always 1. Doesn't matter where I draw this, the denominator. Right? And this is x, y, x, the radius. Doesn't matter where I draw this in the unit circle, my radius is always a unit. It's never 0. Okay, so sine and cosine, the domain and the range are all real numbers. Let's think about tangent, though. Tangent theta is sine theta over cosine theta. So where would tangent theta be undefined? Where this is 0. It can't exist where the denominator is 0. So it's considered undefined at that point. Okay? So where is cosine theta equal to 0? What's that? Think of your 4 points here. And the fact that xy means cosine sine. So this point is 1, 0. So that's where sine is 0. This is 0, 1. So there's where one place, but cosine 0.
And then 0 negative.
Yeah. So there's another. Okay. So the domain of tangent is all reals except for pi over 2 negative, or pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Anytime it lands here or here, as we keep going around and around and around the unit circle, tangent will always be undefined. Right? So we call that, I want to do pi over 2 plus, what do I want to do? I don't want to call it some constant because, so it would be, well, we'll just go 3 pi over 2, 5 pi over 2, etc. It's undefined. Okay, so the domain would be anywhere but those places. Okay, cotangent is going to be 0 and pi. Okay, cosecant is going to be anywhere that y is 0, so 0 and pi. Secant will be anywhere that x is 0, so it would be pi over 2, pi over 3, pi over 2, etc. So tangent and secant have the same domain. Cotangent and cosecant have the same domain. With me still? Actually, it should be, yeah, that's right, because cosine's on the bottom. Cosine's on the bottom for secant. Tangent and secant, cotangent, cosecant. Okay, one last piece of information here. Okay, so if theta is here, negative theta is here. Negative theta. Can't draw negative. Okay. So sine of theta is going to be y over the radius, right? Sine of negative theta is negative y over the radius. You follow? So to find sine of negative theta, I'm just going to change the sign of sine theta. Okay, so let's pretend we have a 3, 4, 5. I know this is a unit circle and that's always supposed to be 1, but just 3, 4, 5. Sine is 4/5. Sine of negative theta is negative 4/5. So I just took the opposite of whatever sine of theta was. Okay. Cosine, though, you can see in the x direction, it's positive for both. And x is what I use for cosine. So cosine of negative theta is just whatever cosine of theta is. Okay? And then tangent of negative theta, because it's the sine theta over cosine theta, and sine of negative theta is negative sine theta, cosine negative theta is cosine theta, it's equal to negative tangent theta. Okay, so a lot of these you'll feel like you need to memorize, but you really can figure them out if you can't remember, just by drawing triangles and asking yourself questions. Does that make sense? Okay. All right, I think that's it for 1-6. But make sure you've read the textbook and watched the videos, because that will help you a lot.